Hello, everyone. Can you all hear me? Hello, if you can hear me, kindly notify yes, you can hear me. Okay, very good. Yeah, good evening, everybody. Who was the first person to come today? Who was the first person to join? Is it Stanley? Okay, so who was the first person? Okay, is it Chinelo? Chinelo was the first person. Oh, okay, okay, okay. So Chinelo, send me your phone number so I can send you recharge card. Okay, so just like we know, we are seeing further maths today. I'm trying to get my slide. I'm trying to upload my slide. So give me some few seconds to upload my slide. Okay. Okay. By the way, while we are still waiting, okay, my slide is taking time. So let me share something else. Okay. Can you see my board? Okay. So now today we are going to start with definition of terms in sets. I started set theory, so um, we'll look at definition of terms in set. Okay, so that's what we are looking at. Definition of terms in set. The first thing we are going to look at is what we call elements of a set. Okay, now the elements of a set are members of a set. So element of a set are members of a set. So if I write this, means X is an element of A. So if I write this is the symbol for element. So when I say XEA, it means X is an element of A. This symbol here simply means element. Okay. Okay. So if I have something like this, the topic is sets. So if, let's say, we have a set P to be equal to A, E, I, O, U, for example, then we can say that A is an element of P because A is a member. I is an element of P because we have I in this set. U is an element of P because we have U in this set. K is not an element of P. This is how you say not an element. You write E, you write that symbol, then cross it. I want to be sure that we understand that. Do you understand? Please, if you understand what I just wrote now, notify. Say, yes, I understand. Genesis, are you just coming? I'm very, very sure that those that don't understand were not in my last class. I'm sure that those that don't understand were not in my last class. So remember, we said that set is a collection of objects. Okay, a group of objects enclosed in a bracket, in a coily bracket. The way you represent sets must be represented in a coily bracket. Okay, so when you write anything here separated by a comma, it means that A is a member of this set, E is a member, I is a member, O is a member, U is also a member. So being a member of this set, it means that A is an element of set P, E is an element of set P, I is an element of set P, O is an element of set P, U is an element of set P. Okay? By the way, before I continue, if you have any classmates that is interested in joining our class, I'm starting a new batch on the 6th of July. 6th of July is for a new batch of students, okay? And you can encourage them to join that. The timetable will be such that it won't clash, okay? So that's why we have this. Now, let me give another example. Let's say I have a set A. This set A is -1, 0, and 1. That means this set A has 3 members. Has 1, 2, 3, 3 members. Can you see that? Okay. So that means I can say that -1 is a member of set A because -1 belongs to this set. I can say that 0 belongs to this set, is an element of set A. I can say 1 is an element of set A. But if I pick a number like 3, I don't have 3 in this set, so I will say it is not an element of set A. I can also say 5 is not an element of set A, and so on and so forth. So let me know if you understand that. Well, I want to believe that you understand that. So do you understand that? Okay, I'm glad everybody understands. That's good. That's very good. Okay, so the next thing I'm going to talk about is we call it cardinality of a set. Number 2, we call it cardinality of a set. Okay, this is the number of elements in a set. So cardinality of a set simply means the number of elements in that set. So I can say that hence NA, if I write something like this, it means the cardinality of set A. So whenever you see something like this, now example, let me say I have a set R, and this R is W, X, Y, Z. These are the elements of this set. All you need to do is to count how many elements are in this set. This is 1, 2, 3, 4. There are only 4 elements here. So that means I can just say that NR is equal to 4. That means the number of elements in set R is equal to 4. I hope that makes sense. If you understand what I just did now, kindly notify me. Say, yes, I understand. Whenever you are asked to find the cardinality of a set, just count the number of elements in that set, or count the number of members in that set. In the set R has only 4 members. So you say the cardinality is equal to 4, or you say NR is equal to 4. Let me give another example. Let's say you have let's say you have let's see, is it affecting? Let's say you have set Q to be equal to 2, 4, 6, 8, 10, 12, 14. Let's assume you have something like this. You may help me pick on. Okay, let's say you have something like this. Okay, please give me a second, please. Hello, yeah. Trying to use this is Q. These are the elements of the set, members 2, 4, 6, 8, 10, 12, 14. These are the members of this set Q. So if they ask me to find the cardinality of the set, that means I'm going to write it as NQ. It means count all the numbers. That means this is 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7. So I will say the number of elements in set Q is 7. Or I say the cardinality of set Q is 7. You can't see my screen. You keep disturbing me. I've even lost track of people I'm sending link to. Okay, so this is Q. This is the elements in set Q. 2, 4, 6, 8, 10, 12, 14. But if you count it, this is 1, 2, 3, 4, 5, 6, 7. That means there are 7 elements in this set Q. So I'm going to say NQ is equal to 7 because I have up to 7 elements in this set. Genesis, do you understand now? Okay, Genesis, do you understand now? Okay, let me give another example. Let's say I have another set. Let me call that set B. And the set is, let me say, car, light, air, bus, TV. Can somebody tell me what the answer is for NB, the cardinality of B? Can somebody tell me what NB is? Okay, Gina says 4, Brian says 5. Any other person? Okay, Rubik says 5. Any other person? Okay, Marianne says 5. Any other person? Ami says 5. Okay, I can see that I can see most people are getting 5. Any other person? Chinelo got 5. Darasimi 5. Okay, that's very good. So I'm going to say that NB, let's count. So this is the first one here. 1, 2, second element, third element, fourth element, and fifth element. They are separated with a comma. So NB is equal to 5. So if you got 5, then you got that answer correctly. I think you deserve a handshake. If you got 5, you got the answer correctly. Is Genesis still here? Good. I'm happy with your responses. Now brace up because it's going to get tougher as we continue. This is just the sweet part. You know, I'm still romancing you. Okay, so that is that. Now the next thing I want to talk about is that's number 3. Number 3, we call it a subset. Okay, so the subset of another set. Okay, no, let me put it this way. Sorry. Let me put it this way. A set A is said to be a subset of another set B if all the elements in A are also in B. Okay, so that's that. A set A is said to be the subset of another set B if all the elements in A are also in B. If all the elements in A are also in B. So let me give you guys an example. Okay, please give me a second. Let me check something. Oh, okay. Don't worry. I have my phone here. Okay, are you guys done writing this? Are you guys done writing this? So let me give an example here. Let's say I have a set. Okay, so I want you to look at set A. Set A has only 3 elements, 2, 3, and 4. Set B has 6 elements, 1, 2, 3, 4, 5, 6. But I want you to notice something. All the elements in A are also in B. You can see 2 here, you can see 3 here, and you can also see 4 here. So I can now say that hence A is a subset of B. This is how you write it. This is the symbol for subset. This is how you write it. A is a subset of B. A is a subset of B. That's how you write it. Okay, so let me know if you understand that. Let me know if you understand that. Okay. Okay. Gina understands. Darasimi understands. Who again? Chinelo understands. Okay. Okay. Miriam. Okay. Rubik's understands. That's good. Okay. That's very good. So let me also add something. Let's say I have let's say I have another set C. Okay, now I want to tell you, I want you to answer true or false. Now answer true or false. Is A a subset of C? Is A subset of C? I want you to answer true or false. Is A subset of C? Answer true or false. Okay, Brian says true. Darasimi says true. Kenzie says true. Mackenzie. Okay. Okay. I like our responses. The answer to that question is false. 2 is here, but there is no 3 here. Even though there is 4, but there is no 3. So A is not a subset of C. Remember the definition for subset. If a set A is a subset of another set B, then all the elements in A, you must find them in B. All the elements in A, you must find it in C. Okay? Let me get something quickly. So false is the answer. Does it make sense? Okay, I like what you guys are doing. I'm trying to get a question to keep us busy, to be sure that we understand it. Okay, I want to share another screen. Okay, look at the screen I just posted. The question says, which of the following are correct statements? Which of the following are correct statements? You have a set A to be equal to this. Then this one says this. Okay, so tell me what the answer of A is. Let's start with A. You know, we have A, B, C, D, E, F, G, H. Okay, so what is the answer of A? Anybody? Is A correct? I don't think it's my screen. Refresh your own screen. Refresh your screen or increase your resolution. Increase your resolution. Yeah, the question is A true? You know, we have different, so A, is A true? Okay. I like the answers I'm getting. Yes. Yes, A is true because 2 is a member of this set. 3 is also a member of this set. So this is correct. This is correct, right? So if you get that correctly, then you should celebrate. Okay, that's good. That's good. Okay, look at B. Is B correct? I like the confusion. I like the confusion I'm seeing. Rubik's, take it one step at a time. Okay, let me help you out. Now, this symbol here means subset. Then if I cross it, it means not a subset, not a subset. So 1, 2, 3, 4, 5, 6, 7 is not a subset of 1, 2, 3, 4, 5, 6 because 7 is not here. So this statement is true. You need to know your logic. You need to know your logic. B is correct. You need to know your logic. Because once they cross it, it means it is not a subset. And that's correct. It's not a subset. I'm teaching you to have a brain of a further mathematician. Yeah. Hey, that's interesting. Very, very interesting. Okay, so let's see. Okay, so can somebody tell me about C? Is C correct? Okay, C is not correct. That's beautiful. That's beautiful. That's beautiful. So I'm going to write false here. Okay, what of D? Is D correct? What of D? Is D correct? Okay, some say true, some say false. Okay, now this statement means this is not a subset of A, and this is A. And truly, this is correct because this is not a subset. I cannot find 7 here. Everything here is not here. 7 is not here. 3 is there, 5 is there, 1 is there, but 7 is not. So this statement is true. So it is not a subset of A. Yeah, I like that, Marian. It is very much correct. Yeah, not a subset. So that set is not a subset of A because of 7. 7 is not in A. You see, so you need a thinking of a mathematician. Okay, what of E? Is E correct? Okay, E is correct because one, there is one here now, and that's the only set here. So yes, it is correct, true. Stanley, I wonder why you are confident with the wrong thing. Okay, Dojan, you're welcome. F is correct. Is F correct? Okay, everybody's correct. Everybody's correct. Yes, F is correct. Okay, now, don't say, yeah, I like that. I like that. Now, don't say anything about G and H. Now, G and H, I will talk about that later. G and H is correct. Yes, an empty set is also okay. No, G is not correct, but H is correct. I will explain that later. Don't worry about that. I will come back there. So let's go back. Okay, now let me say this. Please note this before I continue. If A is a subset of B, we write it like this. Therefore, B is a superset of A. We'll write it like this. So, just the same way, you can't see my screen. Can you see my screen now? So, if A is a subset of B, it means that B is a superset of A. It's just like when you say, it's just like when you say 3 is less than 5. It also means 5 is greater than 3. 3 is less than 5 also means 5 is greater than 3. So if you say that A is a subset of B, it simply means that B is a superset of A. I hope you understand that. Do we understand that? If you do, let me know. Okay, good. So if I am a subset of U, it means that U are a superset. It's just the reverse, just like greater than and less than. So that's the same thing with superset and subset. Okay? If A is a subset of B, it means that B is a superset of A. It's just the same thing. Okay? So that now leads us to the next thing. Okay. The next thing we are going to define, number 4, is what we call empty or null sets. So an empty set or a null set is a set that has no element in it. Okay, so it is written as this is the symbol or this. So it is either you see like this or this. Can you recognize that symbol? It's either you see it as file or just empty bracket. And I like you to note something here. Note, an empty set is always a subset. An empty set is always a subset. So when they are asking you something about subset, empty set is always a subset. For example, an empty set is a subset of 1, 2, 3. An empty set is a subset of 2, 4. Empty set is always a subset. So anytime you understand something about, anytime you see a question about subset, always know that empty set is always a subset. Empty set is always a subset. I hope that makes sense. Very good, very good. Okay. Now, the next thing I want to talk about is the next one. Let me say number 5. We call it finite sets. Okay, so a finite set. Okay. Am I still frozen? Okay, good. So the next thing is what we call a finite set. A finite set is a set that has a beginning and also has an end. That's what a finite set is. A finite set has a beginning and also has an end. For example, something like this. Something like this is a finite set because it starts with 1 and ends with 4. So P is a finite set because it starts with 1 and ends with 4. So any set that has a beginning or has an end is a finite set, or you can call it a finite set. Can you guys hear me? Okay, can you guys hear me now? Can you hear me now? Okay, very good. So we said that a finite set has a beginning and also has an ending. That means it starts somewhere and ends somewhere. But an infinite set, okay, good. So a finite set has neither a beginning nor ending nor both. Now, this is how you know a finite set. For example, look at this. Now, do you see something like this? This is 1, 2, 3, 4. This dot, 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 dot means that it continues to infinity. It keeps going. It keeps going. Do you understand? So this set A has a beginning but does not have an ending. Do you understand? Yes, it has a beginning. Yes. It may not have a beginning or may not have an ending or both. Look at this. This is also a finite set. This one doesn't have a beginning, but it has an end. This is also an infinite set. This one does not have beginning, does not have end, is also an infinite set. Any of them means infinite set. Any of them means infinite set. I hope that makes sense. Any of them means infinite set. Yeah, one is the beginning, but it doesn't have an end. So it is either you don't have a beginning, or you don't have an end, or you don't have both. All of them are infinite sets. Does it make sense? It's either you don't have a beginning, or you don't have an end, or you don't have both. Okay, I hope that makes sense. Good. Now, let me give you another example of infinite set. If I say you should write a set of, if I say write a set of even numbers, can you finish writing it? Is there anybody that can finish writing the set of an even number, of even numbers? Is there anybody here that can write all the set of even numbers? Good. Chinelo just spoke like a mathematician. It is infinite. It is infinite. It is infinite because even though it may start with 2, it keeps going 2, 4, 6, 8, 10, 12, 14, 16. When are you going to stop? I can assure you that even till you get to 150 years, you will not finish counting even numbers, right? So that is an infinite set. That kind of set is an infinite set. A finite set has a beginning and has an end. An infinite set does not have a beginning and does not have and does not or does not have an end, or both. Okay, I want to see if I can get a question. The reason why, I hope I am not boring you with questions. The reason why I'm taking my time is so that everybody will understand it. I want everybody to understand it, right? I wanted the class to end by 9, but I don't know if I should stop now. Okay, so look at that question I just dropped now. It says, state whether the given set is infinite or finite. State whether the given set is infinite or finite. Well, some people call it infinite or finite, but I prefer finite, infinite. So the first one is what? Okay, I'm seeing our answers. Yeah, keep it coming. I like that. Chinelo, an extra 100 naira for you. An extra 100 naira recharge card for you, Chinelo. All your answers are correct. So you guys are doing a good job. Brian, you said what first? No, I think Chinelo wrote all the correct answers first. Okay, so number one is infinite. Number two is finite. Number three, infinite. Number four is finite. Ami, you got this wrong. It has a beginning and has an end. The beginning is 20, the end is 200. Don't mind this. This one only means that there are some numbers in between. Yeah, there are some numbers in between, but it is finite. It has a beginning and has an end. Number four is finite, is finite. Are you guys getting this? Are you getting this? Okay, I like that. Okay, so yeah, you're welcome. Okay, so number seven. I will call number seven intersection of sets. Okay, so the intersection of two sets are elements that are in A and also in B. And this is what we write it. We write it as A this B means A intersection B. Yeah. Now I want to give you an example. So let's say I have a set A to be now look at these two sets. Set A contains 2, 3, 5, 7, 11. Set B contains 3, 5, 7, 9, 11. And I'm asked to find A intersection B. I'm asked to find A intersection B. Can you see that? Now, A intersection B means what is common between two of them. Solution, this is what I'm going to do. I will say A intersection B is equal to what is common. 3 is common. We have 3 here. We have 3 here. So I'll write 3. 5 is common. I'll write 5. 7 is common. I'll write 7. 11 is common. I'll write 11. So this is the answer. So A intersection B is equal to 3, 5, 7, and 11. If you understand it, say yes, I understand. If you don't, say I do not. So intersection between two sets simply means elements that are common between the two sets. If you understand, you say yes, I understand. If you don't, you notify. Okay, intersection means what is common between two sets, but subset means that it's a junior brother of another, or one is the child of another. That means every element in A is also an element in B. But this one is not subset. A is not a subset of B. A is not a subset of B, and B is also not a subset of A. If you check, there is 9 here, there is no 9 here. And here there is 2 here, there is no 2 here. There is, okay, I think that's it. I hope that makes sense. Good. Good. Let me give one more example, then we call it a day. So now you guys do this for me. P is equal to Okay, you guys can go ahead and find P intersection Q. Go ahead and find P intersection Q. Go ahead and find P intersection Q. Okay, I need more answers. Okay, I like the answers I'm getting. Is blessing. Blessing wrote like a professional. She wrote it exactly. She used the kind of bracket, which is a coily bracket, and she wrote it exactly how it should be written. So everybody should look at blessing. So blessing, send me your phone number so I can send you 100 naira recharge card. That's an amazing one. The bracket must be coily. Yeah, I think Stanley did the same thing, but you don't say 2 and 10. You just say 2 comma 10. 2 comma 10. Okay, I think we can call it a day here. I've tried for you guys, but I'm glad you understood what I showed you guys today. So we are going to practice more. I will send you more questions. At this point, I will say have a nice day. See you in our next class, okay? Bye-bye. Good night. Bye. You're welcome. You're welcome. Bye. Good night. Good night. Good night. You're welcome. See you in our next class. You are welcome. Bye, Stanley.